Okay. How much time do I have?
15 minutes.
Pardon? Okay, that's about right. El Nino and California flooding. Again, one of the misconceptions. So all the red lines are years when there were the pinkish line are the weak and moderate El Ninos. The solid red lines are strong and very strong El Ninos. The blues are La Nina years, weak and strong. And then the green lines are neutral years, when you don't have either one. Some people might call that a La Nada year. If we look at the top 10 events here, and it falls out nicely at about $500 million, so it'd be right across this line here. Of those, 4 of those were El Ninos, 4 were neutral years, and 2 were La Nina years. We can get big flood events in non-El Nino years. Actually, we are more likely, 6 of the 10 are not El Nino years of the 10 worst flooding events. So here's our 97-98 El Nino. It's number 10 on the list. What made that really different and would be the ideal scenario for this year? So you sort of had on average that 150, 200% of normal rainfall across the state, pretty much universal from the Oregon border down to the Mexican border. That was spread out over about 150 to 200% the normal number of rainy days. So San Francisco normally gets 67 rainy days a year, so more than 100th of an inch. In 97, 98, they had 122 days of rain. So you take the rain, you spread out over more days, you don't have the big intense periods. And so that is why 97, 98 did not have a lot of flooding in the state. You had a lot of mudslides, because things were saturated, you get a lot of rain, you had a lot of agricultural damage. A lot of the dollar value in here is agricultural damage, because they couldn't get into fields to plant, and they lost all sorts of agriculture that way. Some minor areas of flooding, but you did not see the big rivers getting really high because it was metered out over an extended period. ARs, atmospheric rivers, are what cause California flooding events. That's what an atmospheric river looks like. Big tap of precipitable water going back down into the subtropics, sitting focused over an area of the west coast, in our case, South Carolina, with the moisture coming from Joaquin a couple weeks ago, where you have a prolonged tap of moisture, lots of embedded little short waves bringing impulse after impulse in over an area, averaging from 100 to 200 kilometers in width, and sitting over an area from 3 to 5 to 7 days. This is what the atmospheric river, which was back in New Year's Eve of 1996, New Year's Day of 1997, looked like on visible satellite image. We called it the Pineapple Connection or the Pineapple Express then. I'm glad we have, that sort of has lost favor. Fine with me. These are the sorts of rainfall numbers that we saw. These black areas are all greater than 8.5 inches of rain. This is the one-day rain embedded for what was embedded in that. And all these purples are up in the and dark blues are in the 5+. So huge amounts of rain. So this is what causes most of the flooding in California, not El Nino. The question then gets asked, well, are there more El Ninos are there more atmospheric river events during El Nino? And no, they're about the same numbers, but because of the warmer atmosphere, the warmer waters, they tend to be stronger and wetter than they are. So not much change. The number of events, increased precipitation in California. They are typically warmer, so that the snowpack is less. And that gets me off into one of my more recent soapbox issues, is how important is the snowpack, unless you're a skier? Because I would rather have like an event like we had last December, Good atmospheric river event focused into the northeastern part of the state. Very high snow levels, but tons of water content. Shasta came up 20 feet or some ridiculous number in a week's time. If that had been from cold storms coming out of the Gulf of Alaska, you would have had about the third the amount of water getting into the reservoirs. Now, in a normal year, when you have reservoirs that are up near the top, for flood control, you have to leave a certain amount of water mandated by the Army Corps of Engineers for flood control. So you don't have all this rain come down, top over, go over the spillway and flood out downstream areas. That's not a problem this year. So I'd much rather have, sorry for you people who are skiers, have a lot of these warm, wet storms with a higher snow level, and it averages about 1,000 feet higher during El Nino years than a lot of cold, fluffy powder. What I like to refer to as the whole alphabet soup of other indices going on, and I think this is a big player in why all El Ninos are not the same. Now, other than the seasons, El Nino is probably the most significant climatic aspect that affects a season's weather. But it's, so it's sort of the superstar in the game. Think of it as Curry for the Warriors. Okay, but you have lots of other players who make contributions. Sometimes they make Curry score more points, sometimes they score a lot more points. That's things like the Pacific Decadal Oscillation, the North Atlantic Oscillation, as I mentioned, Julian, this whole alphabet soup, as I call it, of abbreviations. Sometimes those are positive feedback for El Nino, sometimes they're negative feedback. One of those is the Pacific Decadal Oscillation. This was found, was documented first in '96 up at University of Washington by a marine fisheries person looking at salmon production populations and looking at temperatures of the Pacific Ocean between 20 degrees north and the pole. And he noticed that there was this component that took place every 20 to 30 years. So they kind of like to use the average of 25. That you would have what they call the warm phase. So the bulk of the Pacific was warmer than normal, and then the cool phase, where where it was cooler than normal, when we look at the warm phases, but they were again this 30-year period from 26 to 46, and again from 77 to 98. So. This one in here, so this is back to the, so if you remember back to the Southern Oscillation map, these all very well correspond to the warm phase of the years when there were more and stronger El Ninos. So again, our 82 event, our 97 events, several other El Ninos in this area. More La Ninas here from the late 40s into the mid 70s. So again, this is one of those positive feedback mechanisms that go into the into how strongly California rainfall is affected by a El Nino. For those who haven't seen, this has been a while, but if you're still looking for that costume for Saturday night, here's what you can do. Questions? What's that?
Don't be shy.
Don't be shy, or y'all want to go home. I know.
No.
Yeah.
So I don't know too much about this, but so last week there was maybe earlier this week, the Patricia hurricane, and like that was one of the strongest hurricanes.
Right.
Is that the sort of thing that could take energy out of the El Nino event, or is it just those?
No, I think Patricia was probably enhanced by the warmer waters and the jet stream pattern that we have seen that has basically killed the Atlantic hurricane season, enhanced the Eastern Pacific hurricane season. We have all that warm water along the Mexican and Central American coast arguably that some of that may or may not be due to El Nino, but the whole tropics and on up into that area is very warm. It's just such a target-rich environment. It's not surprising that we've seen, I think, more Category 4 storms than we've ever seen in the Eastern Pacific, and as well as what happened with Patricia. It's really an interesting commentary about people talking about how the forecast for that was such a bust because enough people didn't die, there wasn't enough damage. Well, fortunately, it hit a relatively unpopulated area between Puerto Vallarta and Manzanillo, and it was luck. It did not do some of that other damage.
I guess I was wondering, can that sort of thing take energy out of the El Nino, or is it
No,
not
I wouldn't think so. The scale of that is I think way too small.
So then from a climate perspective, how will El Niños change, do you think, in the future? Has there been studies about how the patterns might, since we only have 2 records of the strong ones?
Of the very, very strong, yes.
Yeah, of the very strong. Is that something that is going to?
That is the sort of probably the leading supposition is that with a warmer climate, the ocean's going to be warmer, and you're going to see sort of all the El Nino events ratcheted up and being at a warmer level. So I would expect we would see more strong and very strong events going forward.
Have there been any attempts to kind of like determine, I guess, ENSO events in the past? I guess maybe like looking at like records of like the Peruvian fisheries or before the data analysis that's kind of used in the 50s or I guess satellite.
Yeah, this data goes back to 1950. The data set I mentioned at the beginning I've been looking at is from other ship reports and this Hayden Observatory data from England that goes back to the 1870s. And then there's anecdotal data from looking at rainfall records and sea surface temperature records along the South American coast going back to 450 years. So yeah, there are some reconstructed histories that go back that far. Obviously, the farther back, the more proxy data you use, the less accurate it's going to be. But it's going to give you some ideas. For example, the big California rainfall event of 1861 and 62 was not an El Nino year. So by looking at some of these other events, we can at least put them in some sort of perspective and see whether that might have been a factor or not. Thank you for having me.
Thank you, Jeff.